Well, hello everyone. Thank you for joining. Today is a pleasure for me to present Matías del Campo. Please keep your cameras and microphones off until the end of Matías' presentation so we can have a Q&A session afterwards. This is the first encounter on the topic of artificial intelligence and architecture we are having in the Institute of Architecture. On Friday 22nd, Daniel Boloshan will be lecturing on his recent work presented by our local reference in architecture and AI, Federico Menichetti. And this interest in AI enters a fundamental topic regarding the first annual series of the Institute, that is architectural form. We started this series in December 2021 with a lecture by Peter Eisenman, and since then we have discussed how the architectural form is being thought today based on approach from systematic generative organizations, complex geometries, simulation software, animation, and now artificial intelligence. In this context, we have named these fall activities emergent form. Although this term may have changed a lot since the ideas around emergent organization a couple of decades ago, it is still an interesting topic of discussion how we can generate form building a distance from authorial drive. Artificial intelligence, it's not a new thing, but for the first time architecture is starting to explore the capabilities of AI in a more and more precise way, acquiring new tools and technologies towards speculative design and projective theory. Dr. Matías del Campo is a registered architect, designer, and educator. He's an associate professor at Tauman College of Architecture and Urban Planning at the University of Michigan, director of the Architecture and Artificial Intelligence Laboratory at UOM, an affiliate faculty member of Michigan Robotics. Matías del Campo is co-founder of the architecture practice SPAN. Their award-winning architectural designs are informed by advanced geometry, computational methodologies, and philosophical inquiry. Most recently, he published AD Machine Hallucinations, Architecture and Artificial Intelligence with Wiley, and his book Neural Architecture, Design and Artificial Intelligence with Auto Editions. So thank you very much, Matías, for doing this. It's a pleasure for me to have you again.
Santiago, thank you very much for the generous invitation and the introduction. I'm very happy to be here today and have the opportunity to talk to you and your students about some of the ideas and things I've been working on regarding AI and artificial intelligence. So I'm going to start sharing my screen here, and I hope it's going to work. Let me know if you see the presentation.
Yes, we're seeing.
Okay, excellent. Excellent. Okay, so just 1 second here. All right. As Santiago mentioned, I founded SPAN Architects together with Sandra Manninger. So here today. The lecture I'm going to talk today about is called Neural Architecture, Design and Artificial Intelligence, and basically subsummarizes some of the ideas, possibilities, opportunities within the emergent field of AI and architecture, which have seen, I would say, an explosive growth within the last 2 years, and even more so in the last couple of months. The development is really very quickly and surprisingly, even surprising for me, who is a big believer into this whole idea. So the book that is getting out with oral editions basically starts with a chapter called This Building Does Not Exist, which is an attempt at a theory of neural architecture. And it continues with ideas on computational vision as a design method, to questions of style in artificial intelligence and architecture. It contains also an entire chapter on aspects of language and architecture, which has become very current with the emergence of Disco Diffusion, Midjourney, and DALL-E 2. Chapter 6 deals with the important question of how machines learn to plan, and continues with the question of applying 3D mesh models in neural network algorithms, one of the major research areas at the moment. The book ends with a statement about the politics of neural networks and artificial intelligence. Mario Campo was so kind to provide the preface of the book, which consists of a fascinating story about the compositional technique used by an ancient Greek sculptor named Zeuxis in the creation of a Venus statue, which he compares to the generative adversarial networks that powers a lot of the designs in the book. So what is neural architecture? It is the field of architecture that is primarily preoccupied with interrogating the emerging field of artificial neural networks as a method of designing architecture. Ein-Ends can be described in short as a sequence of mathematical algorithms that are capable of registering latent correlations in a set of data. The content of the book primarily presents or uses deep learning and machine learning to capture the salient features of existing architecture in order to interrogate this data for their underlying architectural qualities. But let's start with the main basic question, why use an AI at all? There's a short answer to that, and there's a long answer to that. I'll give you the short one. It's better to teach machines how to learn instead of how to do things. What does it mean? Teach machines how to learn instead of how to do things. I'll give you an example. So generally speaking, it's better to teach machines how to learn instead of how to do things. Let's just see if I can turn off the sound here for the videos. So generally speaking, it's better to teach machines how to learn instead of how to do things. What is meant by that is for example, this example about welding the parts of a car. So you see this is a video from 1973 on the left side from Volkswagen and a video from 1962 of Ford in the Dearborn assembly line. So not much change in that decade regarding how cars were assembled. The biggest change that came up was with the introduction of the industrial robot, which was for the first time used by, I think, General Motors in New Jersey with a robot called Unimate. And basically, what is really amazing about this is the possibility to have robots that basically are able to assemble over and over again cars on an assembly line. Just a quick question: do you hear the video of the sound of the video?
No, we're not getting sound. Yeah.
Okay, awesome. That's exactly what I wanted to hear. So what happens here in this video is that there is a huge number of industrial robots putting together carrosseries of cars. Now, for each of those welding points, the robots have to be trained specifically. And you all have seen probably one of those controllers that are next to any industrial robot. And an experienced person literally had to teach a robot point by point where to weld the car that is currently on the assembly line. This is a very costly and time-consuming method of creating a program for a welding robot. Now, because the car industry started using robots in the late 60s and then more and more so in the 70s and 80s, they collected basically millions of data points about where cars were welded. These data points can be actually used to teach a machine learning process out of those millions of data points what it means to weld. So what you're trying to do here is not to teach a robot specific points of a specific car that needs to be welded, but rather what welding actually is and what a good welding point actually represents. This means this whole system can be changed to have robots that basically are able to know or understand what a good welding point is. So with the help of machine vision, every car that comes along this assembly line gets autonomously welded by the robot, which also means that you don't have to produce millions of the same car to make it rentable to use the robots. But basically, every single car that comes along the welding at this assembly line can be different. And that's actually the amazing part about using neural networks for this sort of work. So after the quick question of why to use an AI, there's a question, of course, of what AI actually is. In computer science, artificial intelligence is defined as the study of intelligent agents, which includes any device that perceives its environment and takes actions to maximize its chance of successfully achieving its goals. So, for example, the robot I mentioned before, it wants to successfully achieve the goal to weld a car. In general, the term artificial intelligence is applied when a machine mimics cognitive functions that humans associate with other human minds, such as learning and problem solving. It is, however, really an umbrella term. There's like a variety of ideas around AI. There's the Bayesians, there's the analogizers, symbolists, evolutionaries, but there's also the connectionists. And the idea of connectionism is basically what drives the vast majority of the things we see today in terms of applications in AI. Connectionism's basis is the idea of artificial neural networks. And what they do is basically emulate whatever happens in our mind regarding certain processes. We don't know how all these processes really entirely work. We don't know how we form a thought, for example, but there are certain things that we understand. For example, the idea of multiple neurons being able to transfer information or extract information from data that we as humans ingest. Yeah. But you have also to understand how far away we are of really emulating a brain. A brain has approximately 86 billion neurons, and they are firing on a rate of up to 10 by the power of 15 synaptic reactions per second. Yeah. So this is an enormous amount of calculation power that we have in our mind, and we understand very basically what is happening there, and are able to emulate that by creating mathematics that at the end allow us to integrate that in an algorithm that we can use on a computer. But we really don't know how the mind works yet. We don't even know exactly how human intelligence works. And for example, one of the really largest mysteries is how our brain can calculate these massive amounts of information with such a little amount of energy. But let's go on and maybe have a look at one neural network you might have heard about, which is the GAN, Generative Adversarial Network, which basically consists of two networks. A generator network that basically takes random noise and has a data set with target samples and is supposed to generate images based on the target samples. A discriminator network, after that, basically decides whether the image that was created by the generator network is real or fake. When he considers it to be fake, it sends it back into the generator network in a backpropagation channel, or it is real, and then it goes into the continues into the discriminator network with a discriminator loss. What this means, oh, by the way, this idea was created by Ian Goodfellow and presented in 2014. What you see here is the result of a generative adversarial network. It's an example from the website This Person Does Not Exist that actually can continuously create new faces every time you refresh the page. It's based on the StyleGAN 2 algorithm, which was presented by NVIDIA in 2018. This has been in use for the last couple of years extensively in the arts, in architecture, and in a variety of functions. So after this quick technical explanation, let's go and talk a little bit about the ontology of AI. Where does the fascination come from humans to somehow emulate processes of our minds or thought processes with the help of synthetic matter? There are actually two examples I want to mention here. One being the example of the story of the Golem of Prague, which is here exemplified with the beautiful movie by Paul Wegener from the 1920s, an amazing German expressionist. The golem is an animated anthropomorphic being that comes from Jewish folklore that is created entirely from inanimate matter, usually clay or mud. The story goes that Rabbi Judah Löw used this method in 16th century Prague to create a golem to protect the population of the ghetto. What is most astonishing to me in this folklore, in this story, is that Judah Löw, the rabbi, had to put a scroll with text into the mouth of the golem to bring him to life, which is very akin to scripting or programming. So it needs language to bring an animate matter to life. Language in general, we're going to talk about this a bit later. Another example, which is not in folklore but is actually real, is the story of the Turk. It's a mechanical chess-playing automaton which was designed by Johann Wolfgang Ritter von Kempelen in 1770 and was also presented the same year in the Schönbrunn Palace to Empress Maria Theresia. And to the astonishment of the audience, it could beat every single person who he played against. And it was this box with the Turk on top of it who could move the figures. It toured Europe, and on the tour in Europe, he also beat some astonishing people like Benjamin Franklin, Frederick the Great, Charles Babbage. Napoleon Bonaparte actually tried to cheat, but the Turk actually just swiped all the figures off the board. While it was touring, it also inspired people to think more about automatons and the ways how they can be used in another form than just being entertainment. And most likely actually inspired research, for example, on the automated looms of Edmund Cartwright, but even might have inspired parts of the difference engine by Charles Babbage. This heritage of the Turk is still present today, for example, in Amazon's AI service, Mechanical Turk, which is a popular service when it comes to labor data. However, the automaton, the Turk, was a hoax. There was actually a man sitting in the box underneath the Turk who made the moves. So basically, what I like about this story is that a Viennese hoax basically triggered the first wave of interrogation of automation and also AI, I guess. But if you think about it, also Amazon's Turk is a fake, because it sounds like it would be an AI that labels data, but in fact, it's thousands and thousands of people sitting somewhere in Bangalore that are manually labeling the images. Today, artificial intelligence is deeply embedded in our everyday life, right? Neural networks help diagnose medical cases, make decisions on bank loans, design parole cases, read bank checks, filter job applications, drive cars, fly drones, detect fraud, translate text online, and recommend to you which book to read next. They are parts of the households in the form of quasi-intelligent thermostats and security systems. They help us finding our way in our cars by using adaptive maps, and they're close to the human body in the shape of smartphones and watches, which estimate your health status. They recognize your face and the way you type and help you photograph like a pro, among many other things. The vast majority of those applications we don't even see. The data generated by all these activities aid in perfecting the training of all these algorithms. So in other words, AI is everywhere. So let's talk a little bit about the rise of neural art. You might have seen this portrait before, the portrait of Edmond de Bellamy, which was created by Paris-based art collective Obvious in 2018. It became notoriously famous because it sold at Christie's for almost $500,000, but I don't think that's the interesting part of the story. It is allegedly the first AI-generated piece of art. The name Edmond de Bellamy is pretty obviously a tribute to the inventor of GAN, Ian Goodfellow. Goodfellow, Bellamy. What I think is more important that the price it fetched, or that it is a tribute to Ian Goodfellow, is the questions that actually immediately arise when this piece of art was presented, which is questions of agency, authorship, sensibility, and so on, which are obvious once you start thinking about this problem. Right? I mean, in this case, for example, who is the author? The art collective that came up with the idea to use a neural network, the programmer who set up the algorithm, the hundreds or maybe even thousands of artists who were present in the data set that was used to create this image. So who has the copyright of something that was not created by humans? Of course, the follow-up question is whether copyright is still important. Has it a value? Is it still necessary? The rise of neural art became very visible after 2018, when artists such as Sofia Crespo, Mario Klingemann, Memo Akten, and so on embraced the use of AI as a legitimate form of artistic expression. It cannot be reduced to the visual arts only. Musicians, neural musicians, such as Holly Herndon, Arca, Yacht, and Dadapods, use AI to make their artworks, to make their music. And one of the earliest adopters of neural networks to create works of art is actually literature. So even before we became aware of this existence of this large body of AI work out there, of artists and art tendencies, we were already experimenting around with things like undertraining, overfitting, data scarcity, curious to see what actually AI does with these aspects of their functionality. And after this first modest efforts, we almost had the same questions, or let me put it this way. There were very specific questions about the being, becoming, and the reality of this architecture design methodology. So really interrogating the ontology deeply of what it actually means to work with these tools. And we also had the same questions that the arts had about the agency, authorship, and sensibility in a post-human design ecology. What is the architect's role in a context where the sole authorship is not in the human anymore, but when agency is shared? These questions help in the critical interrogation of designs embedded in a world increasingly entangled with the various aspects of AI. They provided the bedrock for the ontology of neural architecture. In the following, I will focus on one issue that needs discussion in this new ecology of design, which is aspects of estrangement, defamiliarization, and the problem of the new. This is also known as the Entfremdungseffekt, as it was described, for example, by Bertolt Brecht. Defamiliarization, or Ostranenie. I think this is a very interesting possibility to theorize aspects of the designs created by neural networks, or with the help of neural networks. The term itself was coined in 1917 by the Russian formalist Viktor Shklovsky, and here we are again with formalists, and describes an artistic technique that provokes the audience with imagery depicting everyday things in unfamiliar or strange ways. The goal was to provide the audience with the opportunity to gain new perspectives and observe the world through a different lens, through techniques that introduce abstraction into the aesthetics of realism. The concept was influenced, or the concept has actually influenced 20th century art and theory, including Dada, postmodernism, epic theater, science fiction, and philosophy. Additionally, it is used as a tactic by recent movements such as culture jamming. Also, it is the first genuinely 21st century design. How can I do this argument? Well, just think about it. All the computational design methods we have seen in the last 22 years have been actually applied already in the 20th century. Parametric modeling, agent-based modeling, scripting, versioning, blobs, folds, etc., etc. So they have just been refined in the last 22 years, but they were not really something that genuinely was possible now. Neural architecture is a new paradigm, not only intellectually and culturally, but also technically. What we see today was not yet possible even a decade ago. Let me give you a couple of examples of that. First, I want to show you the robot garden. The robot garden, it needed actually a series of geological features. So let me start at the beginning here. The robot garden was actually commissioned by Michigan Robotics for their new building, which was built in the last couple of years, the Ford Robotics building. And they needed next to their building a testing ground for their robots. And basically they were interested in the idea, if we can use the methods that are emerging from their field, like machine vision, to be integrated in the design process. So we partnered up with one of their PhD students, Alexandra Carlson. She in the meantime graduated, to create a series of machine vision processes to make this design, which were, for example, using a data set of satellite images to create variations in the ground conditions. We use 2D to 3D style transferring to create the 3D models. We use deep dreaming to add more features to the site, and combined like a variety of different methods to create this project. It was designed 2019 with the methodologies that were available at the time. We actually really had to search deeply to understand how to create a process, for example, like 2D to 3D style transferring, which actually uses neural networks to apply specific visual information into a 3D model. We also had an interesting conversation about the problem of compressing 3D information into a two-dimensional realm, because you lose information actually when you do that, and how it affects when you fold it back into the three-dimensional space. So there's like really these interesting problems between using methodologies that are novel in terms of how machine vision works in a two-dimensional field, but at the same time being able to talk about one of the older paradigms of architectural production, which is, I would argue, the Albertian paradigm of folding three-dimension into two-dimensional packaging. Let me continue here. I actually received recently this video from the guys at Robotics, which I really like a lot, because that's actually how robots see the robot garden. This perception of field condition through using LiDAR to understand the three-dimensionality of the space, and then basically plan how to walk through that space. In general, I like the idea of how machines perceive the world and how we can basically take these ideas and transform them back into something that we can use as an architecture design. This was the data set of satellite images, or just a very little part of it, because you need actually thousands of these images. This might be just a couple of hundred. And some of the processes used, like 2D to 3D style transferring, in the lower row is some examples of deep dreaming. And I specifically like also these ones because if you think about this, this is a very interesting and strange project, because it was designed by machines for machines, right? I mean, this is definitely like a completely post-human project that does not have to have any human involvement. Now, let me talk a little bit about text-to-image generation. We actually started experimenting with text-to-image generation for a competition in 2020 for the 24 high school project in Shenzhen, China, where we used an attentional GAN, attentional generative adversarial network, that allows for attention-driven, multi-stage refinement for fine-grained text-to-image generation. And they can do that at different subregions of the image by paying attention to the relevant words in the natural language description. So in addition, a deep attentional multimodal similarity model computes a fine-grained image text matching loss for training to the generator. It was trained on the COCO dataset. It's common objects in context. That contains of several 100,000 annotated images that describe objects in the environment. It's one of the main data sets used for automated car driving, for example, or the training of the networks for that. So, and the detailed analysis is also performed by visualizing the attention layers of the attentional GAN. So this project was actually done before things like GPT-2, GPT-3, or Midjourney, or all the things actually appeared. We used actually prompts that were describing parts of the program of the design we had to do in combination with some more, let's say, surreal elements to them. So we said, like, this is the gym. It contains 2 basketball fields, a swimming pool, changing booth, and a cafeteria, and is basically covered with feathers like a bird, for example. Yeah, and with the images that we generated out of them, we used a little bit of Grasshopper voodoo to make the 3-dimensional models out of it, because we didn't have yet the ability to really create 3D models right away from the images at the time. It was also presented in a paper at the Cadre Conference 2021, where we described this process in detail. However, what changed a lot is actually the introduction of diffusion models, GPT-2, GPT-3, DALL-E, DALL-E 2, Midjourney especially, which has made a huge impact into the community, I would say. So how do this actually work? In 2015, something started to happen, which is the possibility for automated image captioning, meaning that at 2015, there were enough images out there that were annotated, describing specific things, like in this case, figures and people and lands and so on, that a neural network was able to recognize those things and create automatically a caption. So in this case, for example, people walking on a bridge. Now, what happens if we take this idea and we turn it around? Instead of having a machine recognize the scene and describing the scene, we describe the scene and it creates an image. This is a popular method, by the way, in computer science to take something that works on one way and then just turning it around 180 degrees and reverse the flow of information. For example, deep dreaming works like that. Yeah? Elman Manisov and his colleagues wrote a paper. He's actually a guy from Amazon's Web Services that describes this method. It was the paper called Generating Images from Captions with Attention. So there's also this aspect of attentional models that I described before in the example of the school. How this works is that basically you take an image and you start adding Gaussian noise to it. So it goes in one direction, more Gaussian noise, more Gaussian noise, more Gaussian noise. And then basically you're able to generate out of that Gaussian noise the desired information based on a specific prompt. Yeah, and this process goes back and forth very often in this algorithm. So it's not a GAN. Okay, it's not a generative adversarial network. It's a diffusion model. That's two different methods, two different ideas. If I use a prompt, for example, photorealistic Palladio villa by night in raining, trending on ArtStation, 4K, high detail, beautiful light, and that's all the text I use, I get something like this. So it's pretty convincing in what it does regarding to creating something that we could read as a Palladio villa. Now, the things I'm interested into are parts of the image like this one, where the model was not able to generate something that convincingly can represent a balustrade, for example, in this case, but a weird agglomeration of strange, raw chunks that are assembled there to visually somehow convince us that this could be a balustrade, but it's actually not. These are the things I like, the mishaps, the things that are strange, that are weird in these processes. However, there's also things like what happens if you just type in, Mies van der Rohe building. It can actually generate quite convincingly images of a possible Mies van der Rohe building. And this is also where I see the biggest danger, or not danger, but one of the things that I'd say I dislike. It's not a danger, it's just something that I don't completely agree with, is that I'm sure that that many people will use these new methodologies to just imitate things that exist. And I don't think that's the space where really interesting things happen. When you elaborate further on these prompts, like in this case, looking down at a fantasy canyon with many buildings in heavy rain, in 3-point perspective, at night, concept art, 4K, trending on ArtStation, Norman Foster, Doug Chiang, windows illuminated, very high detail, 8K, desaturated blue color grade, you get things like this. So it's not necessarily similar to anything we know. It's like a really strange fantasy environment. And by the way, since I actually made these images, I stopped actually using names of architects or styles in my prompts, because I'm more interested into how these new diffusion models can organically create things that I don't know, that are surprising to me. It doesn't mean they're new, by the way. This is a whole discussion in itself, by the way, whether neural networks are able to create something that is genuinely new out of existing data. This might not be the case, but it can actually show us interesting data points in the latent space between the ones that we know. And those might inform us in ways that inspires us to create something interesting. Or it also works with drawings. Section drawing through an opera house. This is not a working opera section, right? It is not a finished project at all, but it might be an interesting starting point. It might be an interesting inspiration for somebody to start an idea on a project. I also had fun doing things like this, for example, just asking an AI, what's the most beautiful house in the world? And you get this here. I have to admit that seeing results like this, I don't think we have to worry as architects that we will be displaced by an AI anytime soon. It still needs a certain amount of imagination, information, knowledge, historical remembrance, and the ability to combine the things in surprising and strange ways to find something in the data sets that really inspires us architecturally to create things that might surprise us and might be showing us a direction we can work on. Now, how do you get those things into 3D? That's like one of the major questions all the time. I'll show you two examples that attempts to do that. The first example is a project called the Generali Center. It's a project in Vienna, in Austria, on the Mariahilferstraße. The current building is from the early 70s. It's more and more it's not in great shape. So we actually thought about what's the alternative for that project. We created a data set of around 2,000 images from brutalist buildings, and let a neural network, in this case a style gun 2, analyze these images. This is a part of that data set. And then train a neural network on understanding the features of those buildings. Like, what are the salient features present in those images, and then how can it generatively use the latent walk to create variations on the topic of brutalism, so to speak. Again, this is also done before I stopped using styles in my prompts and in my research. I think it's more interesting to search for other things, but on the other hand, it is a very architectonic way of working. And then we actually created a pixel projection we selected a couple of images from the data sets and then created a pixel projection to create the 3D model out of it. That worked actually surprisingly well, and we were able to extract a couple of model examples from the data set and then use one selected model, which was this one here, to continue working with it on the project. Of course, it doesn't generate everything that you need in the project, so there's still a lot of curating necessary to create something that is useful as an architectural space. And you see here, we actually slided out the pieces that had to be additionally modeled in order to show like this relationship between the model that was generated using artificial intelligence and the things that we had to add to it. The second example is called the Deep House, also using StyleGun 2. We have a client. He's actually a neuroscientist, and he was interested in basically interrogating or creating a house that consists or has modern features. Yeah. So we created several data sets of facades, rooms, and plans from that era, ran it through a StyleGun 2, and we're then able to, again, create a latent walk between them and find those interesting data points between the existing data to create a variety of elevations and plans for this model. And then we used, again, this concept of pixel projection to assemble all those pieces together into the house. You remember that I discussed these aspects of defamiliarization and estrangement. And what is really funny in this project is that there is enough familiar features for us to really recognize it as a specific sort of modern house. But if you look closer, you will find those moments of estrangement that contain elements that are absolutely impossible to be embedded in a modern house project. At the end, I would like also to mention that I'm one of the co-founders of the Neural Architecture Group, together with Daniel Bolohan and Emmanuel Koh and Sandra Manninger. We founded this group in late December 2020 as a possibility for us to exchange ideas and thoughts, and we try to meet regularly. Please also visit the website aiarchitects.org, where we collect more of these positions so there's like a variety of architects who are present on this website, and we're also adding more and more as we see interesting candidates to be on that website. And I founded also the ARIL, the Architecture and Artificial Intelligence Laboratory at Tubman College. If you're interested in pursuing a PhD in AI and architecture, get in touch with me. We're always looking for interesting people. Last but not least, there is a YouTube channel called Remeshing-AI, where I collect lectures, but also tutorials on how to use some of the Python code necessary to run neural networks. But it has become, of course, more and more user-friendly with the launch of things like Midjourney, etc. The only complaint I would have about Midjourney is that there is no way to see the code, so we cannot change it or play around with it or do different things. In contrast to things like, for example, Disco Diffusion, where you can see all of the code and you can copy the code and play around with it on your own Google Colab. So this is what this lecture was about, the book Neural Architecture, Design and Artificial Intelligence. Recently, also this one was published, Machine Hallucinations, Architecture and Artificial Intelligence, that I co-edited together with Neil Leach. And in fall this year, there's going to be a Springer book called Architecture in the Age of Intelligent Machines, which is more like a comprehensive manual of a variety of networks. So if neural architecture is more about the theoretically discursive side of AI, Architecture in the Age of Intelligent Machines is the hardcore manual that contains the math and the codes behind that. So thank you very much. It was a pleasure presenting to you guys, and I'm looking forward to have an interesting conversation and discussion with you guys.
Okay, thank you, Matías. First of all, it is so nice to know what you're doing right now. We chat a couple of years ago, so it's nice to see how your research has evolved in such intense way, and it's also nice to know that you're working with Daniel Golohan, that is our next guest, so that's so much appropriate. I have a question to start discussing your generous presentation. You talk about not dangers, but things that you don't like about what is happening with some approaches to AI. The question maybe is how we can identify these things that are not, because there's something that is happening in the last months, that is AI has become so Instagram friendly. You can see a lot of images like so easily produced, and they are all beautiful, right? But I don't know how much of those images are thinking about architecture or proposing something about architecture, or I don't know, talking about history or something like that. So is there a way we can identify which is the I don't want to say the correct approach, because I think there is not a correct approach, but an intelligent approach, an interesting approach, something that is really giving something to culture to think about?
Yeah, that's a great question. I mean, first and foremost, I would also say, like you said right before, there is no right approach. There is no recipe, so to speak, doing it right. I don't think that's what the discussion should be about. I can only say from my point of view things that I have observed, where I think like this is maybe more interesting than just repeating things that are around. Because I mean, I've seen like now about like the 50,000 deep fake we've done with Midjourney or something like that, which I don't think is really informative to the discipline or interesting. It's why do that? There is Saadit out there, they have a company. So I'd rather think that I mean, first of all, yes, it's true that like it became Instagrammable. Like all the people, there's like a huge flood of these images now created with diffusion models. Yeah, and I think that's actually good. And the reason why I think that it's good that this exploded in that way is that it might be the first time that a whole group of architects has access to AI at all. Yeah, I don't think a lot of them had. And so, of course, they're not fascinated by it. They're trying things and so on, maybe without thinking too much about it because of the fascination with this new tool, right? So what's going to happen, I think, is that this is going to go on now for a couple of months, and then I think the interest is going to wane, yeah, and it's going to be out of fashion again, so to speak, yeah. But what happens after that is that was the first time a bunch of architects had access to AI, and they're going to start thinking about, like, how can I use this in other ways? How can I use this more intelligently or more informed, or either culturally or technically? I don't mind if somebody optimizes floor plans with it. That's fine. Yeah, but I think there's like these two things. You can use it as something very technical. You can use it very inspirational as a cultural technique. But I think that's what's going to happen in 2-3 months after summer.
Right. Yeah. Yes, because there's an approach that is similar to concept design, maybe, right? Like
yes.
These first stages of a project, of a competition that you can use, like a conceptual thing, but then you have to get in there, right? Like I really like this project that you show, that you generate a 3D model from 2D images. Like you said something like there's not all issues were not solved, right? You get to get in there, right? So that this is nice because in a way you are presenting AI like not something completely new, but something that is shining the tools that we already have, right? You also mentioned that you use also in the project of this high school, you use Grasshopper, so you're connecting this to what we are doing or what we have been doing, right? Like something that is some kind of add-on to the things that we already know how to do.
I mean, I have to say I'm not evangelical about software. Yeah, so what gets the done job is used.
Yeah.
So, but I'm very much interested in infusing that design process with more information that I can extract out of data using AI. I think that's like the most valuable part about it, is that we can. And I didn't mention the projects we're doing in the lab, actually, which are primarily designed to, instead of, or let me put it this way, 2 of the projects that we're doing are about creating data sets for architecture, because they're not out there. They don't exist in the way that we need them to really do something useful and meaningful in AI for architecture.
Yeah.
In order to be able to do this, we need first the data sets to achieve them. Yeah. And unfortunately, like there's only like a very, very small amount of people in the architecture discipline aware that that's a problem. Yeah. So we're working on them, and at the same time, the ambition of the project is to not to keep these data sets for us. We want actually to share them with everyone. They're going to be open source, freely available for everybody to work with them, because I think this is the only way that we can really improve results that we're creating with AI in the architecture disciplines, if we tackle that.
Yeah.
So yes, so these diffusion models are fascinating, and they create beautiful imagery, but it's just that, images.
Yeah.
And for example, I tried to create meaningful plans with that method, but it does not have a concept of what a good plan is, or a sleeping room is, or so on, in a plan. Right. It doesn't understand that. Yeah. So we need first methods and techniques that allow to have semantic information in what we're working with. And this can be 2D, but it also can be 3D, by the way. Yeah. So we can actually work with 3D models if they have the semantic information and everything to generate different approaches to the project, or to a specific program, for example.
Right. Yeah, this is great. I don't know if we have any questions. There, Elizabeth just got in. If anyone has any question, you can do it right now, or I can keep doing questions. So, or even in YouTube, if there's someone, or we have like 10 people talking. So, okay, Piedad is thanking you. So, Thank you, Matías. Okay, I can go on with some other questions. Well, you in the start of the presentation, and I saw this in another presentations of yours. You relate AI with robots a lot, and it's impossible not to, right? Even in science fiction, we're thinking of robots taking control and learning things. But I was thinking about what is the role of people in the design that you are proposing, because something that is nice to see in your designs is that you don't usually put people on your renderings, or you don't put like human figures in the renders. So I think that things like scale are suggested. Things like function are sometimes suggested, and other times it is put on hold, or maybe it is something that you left for the imagination of the people that are seeing the project or trying to understand the project. So I find that very refreshing, because if it's there, something that I don't like is that when you put a person on a drawing, that's immediately architecture, right? Like people give meaning to the drawings, and something that happening with your projects and some of these AI images that appear here and there is that the role of people is not absolutely clear, right? Like we can use these tools to think architecture beyond what people can give to architecture. I don't know if you have a thought about that, like some kind of post-humanism in a good way related to how we represent architecture.
I mean, there's definitely like a strong post-humanist vibe going on in all this work, because basically, I mean, first I have to clarify, because sometimes people confuse that. Post-human does not mean after the human.
Yeah.
It does not mean that we don't exist anymore and then something else comes. That's not the point. The point is of post-humanism, or the post-human in the work that I present, is the understanding that we are not on top of the decision-making process any longer. So that we are not like the pinnacle. For example, when it comes about architecture design, there is this idea of the totally top-down design methodology, right?
Right.
And the post-human approach I take, and others, is basically a bottom-up methodology of designing. And you mentioned that in your introduction, for example, these ideas of emergent design that came up like 20, 30 years ago in the AA and so on. And that this new, there's a new branch of that thinking, right? I mean, if, for example, this sort of older methodology of emergence was really based on generative algorithms that basically can create things bottom up. We're taking another approach in that we scan vast, massive amounts of data and basically try to have an algorithm that makes sense out of that for us in terms of designing. So it processes data in a way that we as humans never could do in our entire lifetime. Yeah. So that's actually for me a post-human process, a post-human design method, because we can actually harness data in a way that we could never do before, in order to improve the hopefully improve architecture at large. Yeah. One thing that I'm very, very suspicious about is this idea of the sole genius in architecture, like the star architect. I think that's very suspicious to me. I think this is just a remnant of 19th century romantic thinking, that you know there's this sole artist who's genius and suffers for his art and so on, and the same thing we've been thinking about architecture. It's a very bourgeois 19th century idea that I don't think we should actually follow any longer. And AI gives us the opportunity to abandon that entirely, because there is not anymore the one deciding person for the design there. It's like, as I mentioned in my lecture, the same problem that happens in the arts. Like, who's the author of this? Yeah, do we
Right.
need the author? I mean, that's like the first question we have to answer. Do we still need the author? Or does it matter that there is an author? I don't think it matters anymore if you use AI, because there's millions of authors. Yeah, like all the artwork that has been annotated, things like ImageNet, for example. ImageNet that gets so widely used in many sorts of AI applications has millions of annotated images by now. Yeah, and every time you tag a person in a Facebook entry, it improves that. By the way, yeah. So I don't think that it's there anymore, but I think we can use this incredible ability, and in my interest is really the latent space between the existing data points that gives us architectural things that I cannot even explain the first time I see them. But the second time I see them, I'm like, oh yes, I can use that. That's interesting. And I think that's where still the role of the architect is, in a sort of guiding this sensing of possibilities in that space. Yeah. So architects always were really good in sensing things. It doesn't mean that they all have to be genius designers, but having the sensory to understand the capabilities of a methodology to enhance the qualities of architecture.
Yeah, or even to construct a concept, right? Because you were saying that there are data sets that are made by a lot of people, but someone made a concept out of it, right? Someone tried to do something with some kind of aim towards an idea, right? That's something that computers can do, but I believe that right now it's difficult to identify, or it's difficult to separate from the free variation images.
I think it also has to do with the fact that, I mean, for example, one thing that has to be said is that we attribute way too much intelligence to artificial intelligence. I don't think artificial intelligence is that intelligent. Yeah. I'm not even sure if it is intelligent at all. Yeah, it's just an unfortunate term that was coined in the 60s or 50s, and it's sticked. Yeah, but it has certain similarities to what our brain can do. But on the other hand, what I definitely agree with, and I'm super interested into, is that because of its qualities to interrogate historical data to an incredible extent, it actually opens new avenues for architecture theory that we did not think about before, right? What do we do with an alien sensibility, like a sensibility that was not created by humans?
Right.
So this is just one of many, many questions. Yeah, we haven't gone through the epistemology of this whole thing because we have not really gone through understanding it in the first place. So that's why at the moment I talk about ontologies, like where the things emerge from, how they come to exist, right? So I can explain how a certain neural network operates, and that's an ontological understanding of that thing. But the epistemology, like really, like this questioning of the results, we are not yet. You know, we are not there yet. But I think it's going to happen fairly soon.
Right. Okay. It's been great, Matías. Thank you very much for sharing your work. Once again, I encourage everyone to look into your books and also to look into the articles that we have been publishing in Antagonismos a couple of times already. And it's been great. I hope we can do this again. I hope you have a good time, and we're going to, of course, edit this, transcript it, and do something, because I think it's important. Even it's getting more and more important, relevant to think about the processes that involves AI. And it's nice what you said about not being I don't know how you exactly say it, but don't get involved in a particular software, but think in AI as a concept that is here to not to change things, but to elaborate on them, right? And it's nice to think that architects have a voice in this, and we can do something about it. We are not artists in general, but we are a specific kind of artist that we can do something. We can generate something more into what is happening in a global sense right now. So, thank you very much for doing this, Matías. It was great.
Thank you, Santiago, for the invitation. It was great to talk to you, and anytime again, whenever you like.
Okay, thanks again. See you soon, Matías.
Bye, everybody.